R.D. Sharma's solution, class 12th probability we are taking. The exercise is the fifth exercise. Arun and Tarun appeared for an interview for 2 vacancies. So there are 2 persons and the probability of Arun's selection is 1/4 and that to Tarun's rejection is 2/3. Find the probability that at least one of them will be selected. So what all is given in the question, let's write that. So this probability, the first thing is Arun is selected, I'm writing it in short, is equal to PA. I'm calling Arun as A, Tarun as B. So the selection is 1/4 here and the Tarun's rejection is given. Tarun's selection is not given, it's rejection. So we are talking about Tarun's rejection. So I'm writing Tarun's rejection in short. Tarun's rejected. Arun selected. So let's call it PB bar. See, positive things we take as A, the against thing we take as bar or complement. So P of Tarun selected is PB. That will be, the selection plus rejection of one person will be adding up to 1. So this will be 1 minus 2/3. This is 1/3. Rejection of PA will be, this will not be used in this question, but the probability of Arun being rejected can be computed like this. If at all it has to be used, 1 minus 1/4, that is going to be 3/4. The probability that at least one of them will be selected, at least one of them will get selected. So this is PA union B. This will be PA plus PB. At least one of them will be either A or B or both of them. So PA plus PB minus PA intersection B. PA intersection B, because of the independency, we can write it as PA multiplied by PB. This comes out to be 1/4 plus 1/3. PA into PB, that is 1/4 multiplied by 1/3. So this 3/4 is not required. We computed it, but it isn't used. So the final result is 1/2. Now this is how you need to do this. And please remember, the selection and rejection are 2 different things. So this one is a good question. We must talk about it in detail because there are questions coming in the later part of this exercise where this kind of question will be used. First is what is geometric progression. The geometric progression is something like this, where we have a common ratio. Every consecutive content or the element of a series will have the same ratio. That is, a square by a is a by 1 is a cube by a square is a. I have written a, but it is actually a cube by a square. So just correct it. So the consecutive, any 2 you take, the ratio will be common. So when you add these series till infinity, it will be 1/1 minus a. A is the first element after 1, or you can call it as a common ratio as well. So A and B toss a coin. It's alternative. If A starts the game, find the probability that B will win the game. So for B to win the game, B has to have a head, A has to fail, so A has to have a tail. B head, A tail. But there are multiple ways in which B can win. So let me explain you how we are talking about this. So a coin can give you head and tail. So head probability is 1/2 and tail appearing probability is 1/2. Now when A starts, what will happen? Because it's being given clearly that A is going to start the game, but B has to win. That means A has to fail. So A first is half, because tail probability of A is half. The probability of B passing is again half, because head is half. Now B has 1. The first head, A fails and B wins. A tails, B head. Now second time what can happen? A tail, B tail. A tail, then B head. Then B will win. All 3 options should be tail. So half, half, half. That is the A, B, A, then B. B is winning here. Now there is a third case and it goes on and on. So it will be 6 times now. So 5 tails followed by a 1 head. So tail, tail, A, B tail, then again A, B tail, then again A tail, then B head. But here head and tail probability both are half. But in order to get another questions where it can be different, this half is all about head and tails. So first one is half into half, that can be written as half square. The second one is half into half into half into half, that is 1/2 raised power 4. Then 1/2 raised power 6. 1/2 raised 8, like that. Power 10, power 12, like this it will go on and on. So you can take this 1/2 whole square, which is going to be 1/4, as outside, as common you can say. the inside will be a geometric series, a geometric progression. So 1 half square, half raised 4, half raised 6. So this inside material or a content, when you divide them, you see this A is representing 1 by 4 here, which I initiated the GP. So it's representing A only. So 1 plus 1 by 4 plus 1 by 2 to the 4, 4 to the 8. 2 raised 4 is 2 to the power 4. That is 2 4 times. That will give you 16. 2 raised 6 is, it's 2 multiplied 6 times. That will give you 1 by 64. So now 1 by 16, if you divide any one of this, 1 by 16 divided by 1 by 4, 1 by 64 divided by 1 by 16, any of you divide, you are always going to get 1 by 4 as the A. 1 by 4 remains as it is, which was the coefficient. We have taken it outside earlier. And this is 1 by 1 minus A. A is what? 1 by 4. So 1 minus 1 by 4 this is. So this will give you 1 minus 1 by 4 is 3 by 4. It goes into denominator. This goes up, 4 gets cancelled, and you'll get 1 by 3 as the result. I hope you got the concept. So this geometric progression will be used in the later part also. So this is how you are going to write it whenever you are writing it. 2 cards are drawn from a well-shuffled pack of 52 cards, one after another without replacement. There is no replacement. One has been taken out, it has been taken out. We are not putting it back. Find the probability that one of these is a red card and the other is a black card. So there are in all 52 cards. When we pick the first card, it can be a red card and then it can be a black card. They are not precisely saying that red has to be the first card or black has to be the second card. So red can be the first card, black can be the second card, and vice versa. Black can be the first card, red can be the second card. So this is how we intersect. So the probability when you add these, this is your answer. So what we are trying to suggest here is that probability of a red and a black card, that is one red and one black card, is going to be equal to probability of getting a red card followed by a black card. The first is a red card. This is what it represents. PR intersection B. The first red and followed by the second black card, and this is when the replacement is not done, without replacement. The second case KB can be first card coming out to be a black followed by the second card which is coming as red. It appears as a red. So this is the probability of B intersection R, which I am representing on the right hand side, which you see also. Now PR intersection B, now you can directly write PR intersection B for this case, and B intersection R for this case. R comes first, black comes second, then black comes first and the red comes second. Now these are independent events, so multiply them. PR multiplied by PB plus B multiplied by PR. You know already what independency means now. Now the probability has to be computed. This is just the explanation. Our all idea is to compute the values. So there are 52 cards. First red is coming. There are 26 reds and 26 black in a well shuffled 52 cards deck. So first is 26 divided by 52 because the red are 56. 52 are total. Now second case, because one has already been taken out, so 51 will remain, but there are still black 26 cards, so 26 by 51. That is why I am writing 26 by 52 for the first red card, and the second black card is 26 by 51. For the second case, black again, there are 26 black, 26 by 52. 51 are remaining now. Now still there are red 26 cards, so 26 will remain as it is. We are not picking up anything from the red card for the second case. This is 26 by 51. Answer will be this one. So this was a good question, but if you want to give more explanation, whatever I have provided, you can do that. Tickets are numbered 1 to 10. 2 tickets are being drawn. Find the probability that the number on one of the tickets is a multiple of 5 and the other a multiple of 4. So it's better always, I always suggest that you write these numbers. So when the sample space is written clearly, the other sets can be easily formed. So the curly braces should be put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are all the tickets which are numbered 1 to 10. I apologize for these square brackets. It has to be curly brackets and all the elements has to be separated by a comma. Now probability of a ticket being multiple of 5. I'm just writing M5 for representation. So there are 10 elements in this set and 5 and 10 are the multiple of 5. So 2 by 10 favorable cases divided by total number of cases. The probability of M4 multiple of 4. How many total numbers are there? There are 10 and favorable are 4 and 8. to 2 by 10. So one of the tickets is a multiple of 5 and the other is a multiple of 4. That is, you need to have an intersection between this PM5 and PM4. But is it being given which has to come first and which has to come second? We'll just see. So the first can be a multiple of 5, second can be a multiple of 4 and vice versa. That's what I've written just now. So I'm just writing M5 and M4 for representation, and now you know that I'm writing it for the multiple of 5 and multiple of 4 respectively. So M5 and M4, probability of getting these two, and this two can be achieved in two ways. First, you get the ticket which is a multiple of 5, and then you get a ticket which is a multiple of 4, or you get the first as a multiple of 4 followed by the ticket which is the number 5 multiple. So we can write it as a PM5 multiplied by PM4 because these two are independent events. So and means intersection here. Similarly here also. So we have PM4 multiplied by PM5. So this will be 2 multiplied by PM5, PM4 because they are exactly the same. So you can just write like this. Now I'm just writing something. Alright, whether it's correct or not, you have to tell me. 2 multiplied by PM5, which is 2 by 10. You know, normal naive person who is just doing the question will do like this. PM5 is 2 by 10 and PM4 is what? 2 by 10. So just multiply this. Are you going to get the answer? Are you going to get the answer? So one after the other at random. So the question is not providing us the important information whether it is done with replacement or without replacement. So if it is with replacement, this is what is the correct version. So we are not replacing it. We are replacing it, sorry. So 2 by 25 is with replacement. But I am just calling it incorrect because this exercise is mostly about without replacement. So when it is without replacement, then what we are going to do? Same thing, but with just reduction of the ticket numbers. Like 2 by 10 is the probability of getting multiple of 5. But when we have taken out 1 already, only 9 are remaining for this second ticket being drawn. So when ticket is being drawn, there are still 2 numbers which are multiple of 4. Similarly, in the second case, 2 by 10, 2 numbers have to be drawn and these are the multiple of 4, 2 by 10. But 1 ticket has been drawn, so 1 has to be deducted from 10. So 9 and 2 still remains as a multiple of 5. So when you compute this, this is going to be, it will be 2 into 4 by 90, that is going to be 8 by 90. 8 by 90 is the result we are talking about. You can write it as 4 by 45. So we are assuming it to be the replacement not done. So this is how this will be done. And now a family tells a lie. 30% cases, husband says a lie. So husband H, 30%. So husband lie is 0.3, 30 by 100. 30% is 30 by 100, which comes out to be 0.3. Now wife also telling a lie, or while wife telling a lie, no, not also, but wife telling a lie, is 35%, 35 by 100, that is going to be 0.35. So wife telling a lie becomes 0.35. They both contradict each other. That means the husband, we are talking or we are calling representing husband as H. So probability of husband, actually it's other way around. We always take the positive thing as H, the negative thing as H bar. So probability of, so I'm just changing this. It's lie, that is why I'm representing it by H complement or H bar. And telling a lie, telling a truth is PH. Similarly, telling a lie for a wife is PW bar, and probability that the wife speaks the truth is going to be PW, which I'm writing it as 0.35, which comes out to be 1 minus 0.35, and that comes out to be 0.65. Now, probability that both wife and husband contradicts. That means if one say truth, the other has to speak a lie, and vice versa. So probability that husband is saying a truth and wife is lying, or in the second case, husband is lying, the wife is speaking the truth. Since these are independent events, we can write it as PH multiplied by PW bar, and this PH bar multiplied by PW bar. So it's not intersection in the second case. Please correct it with multiplication. There is a slight incorrection I have done. 0.3 into 0.35, PH bar and PW also we have computed. So we will write the numbers which are 0.3 multiplied by PW is 0.65. And we compute these two, we are going to get 0.44, writing it in the percentage terms is 44%. So this is how you are going to go about it, and I hope that this can be done by you. It's quite easy now. This question will be taken in the next discussion. Till then, thank you so much. Have a good one.